I posted a video a few days ago of my first cuts here on the plasma table, and since then I've just been trying to get everything working and operating as it should. And basically what I figured out is I don't think I really had a wiring issue, which I was chasing around just because I've never done one of these before, but I did have some issues with the settings inside of the computer and the timing, basically the delay from after the torch fired to the time it takes for the torch height control to turn back on, or turn on in the first place, and then when it's supposed to turn off, how long to delay at the end of the cut to let the plasma extinguish, the height that it starts, the voltage that it is trying to maintain, the speed of travel, all were out of whack. So if you've done one of these before, all that stuff you've dealt with, I'm sure. I don't think I'm the only one here, but if plasma is new to you, like it is to me, all those are going to be part of a learning curve. So I didn't really think about learning to operate the table. All I focused on was how to build the table. So now that it's built, I have to teach myself how to operate a CNC plasma table, which means going from CAD to CAM to actual cutting. So let me show you guys how it's been going so far. I burned through this sheet right here, dialing the machine in, getting it cutting right. I got some good success cutting without the torch height control on, so I would definitely recommend going into manual and turning your torch height control off just to start out with. Having the torch height control off is what got me the best results right away and gave me basically the motivation to keep pushing forward and moving on to the next step. I also started without the ohmic touch, which, let me show you guys what that is. So there's two ways that the machine finds its zero for Z, and in all instances it plunges down. And with the original setup, there's a switch back behind here, and when the torch pushes all the way down onto the material and lifts that whole assembly up, it activates the switch. That's how it sets zero on the machine. And then you have to figure out the distance right here, pretty much, and that's how you set up your offset, because initially it goes down, it's touching the material, and you actually need it to lift up off of the material 0.06 inches for a cut, and I think 0.12 for a pierce, if I'm not mistaken. Anyways, you guys can figure those numbers out. But the idea is that it pushes down and then backs up exactly the distance of that little play plus the amount that it needs to lift up to start its pierce height. So I started with this switch setting my Z0, and eventually after I got that running somewhat okay, I got the ohmic sense, which is the next level of Z control basically. And instead of using the pressure to physically lift up the switch, all it does is senses the ohms, I'm guessing, because it's ohmic sensing. Basically, it's just saying that there's a completed connection between this tip and the material, and that's how it sets zero. So instead of pushing all the way through here, it's a lot more accurate way to set zero, I believe. Okay, so with all that said and done, this is the first cut that I showed you guys the torch diving really bad on. You can see where it didn't even finish these letters. I shouldn't have had torch height control on at all now that I've learned for this smaller stuff, because I think what happens is it gets so close to another cut or existing basically opening here, and I think it just gets so close it gets a faulty voltage reading. You know, this would probably be a good example down in here. If the torch height control kicked on when it got to this point right here, that voltage would probably jump across into this open field possibly and make the torch dive down, the way I understand it right now. Also, this should have had some little pieces connecting it together to keep it inside of there, but you know, that's just part of learning CAM. This whole piece I did with no torch height control on at all, and it did awesome. Every single one of these, I had actually cut out the center of the gear. I just made a really complicated long file to just try and flush out any issues, but without torch height control it worked pretty good. And then of course at the very end of the cut I thought, oh, it's going so well, I'm going to go ahead and turn my torch height control on and then it did this little number right here. So endless frustration with that torch height control, but I think I finally have it figured out now. The next thing I did was I made this little coffee table, just a proof of concept. Obviously, I built the table. It costs a lot of time and money, so I'm trying to start a business with it. Part of that is coming up with some new designs. Obviously, getting the table reliable enough to take orders with is first order business, but I think I'm almost there. And the second thing is to come up with some cool designs that will ship flat and cheap, so I can sell them online. And basically I'm contemplating doing like some DIY kits. So I'm not sure exactly what level, how much pre-manufacturing I should do as part of this kit. Should I pre-cut and drill the wood pieces? This lumber here is just off the shelf at Lowe's. It's a standard size, 1x12, which is actually 11 and some odd, and it's not even 1 inch thick, and it's wood. It's weird. When you buy steel, you usually get extra, and when you buy wood, you get less than what you pay for. So anyways, you can tell I'm not a carpenter. But the cool thing that I learned here on this little project is I don't have a press brake in this shop yet. So if you can see right here, this little tab bent, but I just bent it by hand because I cut a relief notch back in here. If you can kind of see that little cutout right there. Let's see here if you can kind of see. See how there's a relief cutout right there? And it's really only attached right there and right there by a little, 3/16 1/4 piece of metal, which is really easy to bend. So this whole thing could ship flat, these 3 pieces of metal, boom, boom. But I think it's kind of a cool design. Anyways, then the last thing I did before I tore that sheet off of there was make this little geometric fox pattern. You can see right there the torch dived. I had torch height control on up until this point. I was just trying to see what the limitations were. I think I got somewhere around 1/3 of the way through this file before it dived, which means it did all these close little quarters cuts with the torch height control on. Pretty much this section right here was that portion of the tool path, and it cut fine until it got, basically too close to one of these other open areas, and the voltage jumped up and caused the torch to dive. But overall, pretty good resolution. So far, my squares are square to a 32nd. My holes, the top of the holes are 0.011 inches undersized, and the bottom of the holes are 0.055 undersized, which is basically the camber of the cut. So if it's too sharp, that could mean that my torch was a little bit too high, or no, maybe too low. Anyways, I got to figure that out. But so your cut quality gives you a lot of good clues that help you fine-tune the machine. I haven't quite dialed everything in, and I don't understand all of it yet together all at once, but I'm slowly picking up things and working on reducing the dross on the cuts, reducing that angle from the top to the bottom of the cut, and basically just getting cleaner pierces, better lead-ins, lead-outs. There's just a lot of stuff to learn here. You can also see some of these finer details. It's just not picking up. Just not really fine detail work. Same thing kind of up here and up here. But once you get even just to this size, the resolution starts picking up and you start getting within the capabilities of the plasma. This was all out of some 11 gauge. Now I stepped up to a sheet of 1/4 inch material. The voltage changes a little bit. The speed obviously changes. So I was just cutting a bunch of these to test them out, different settings, different speeds, different voltage, different pierce times, and just trying to compare each one of these side to side. And this is basically the happy medium, I think, as far as quality goes. But you can see down here, it's angled on that one edge. These other 3 sides are actually pretty straight up and down. I chipped all the dross off of this, but it was significant. It didn't just come off. I had to use a chipping hammer. And there's certain spots here where the cut didn't even pierce all the way through. But this is the kind of stuff you're going to have to do, is you're going to need to work through a lot of these little issues yourself and figure out what settings affect what part of the cut quality and performance. This one cut all the way through except for right here, which is, I believe, right after the pierce. This is the pierce all the way down this side. So, some issues to work out. But this could also be that it's really small here. And then some of them even got stuck in the sheet. They won't even come out because it didn't cut all the way around. And that's all part of the troubleshooting process. I'm going to go ahead and get this crap cleaned off of here and start cutting this 1/4 inch. I've got a cool project I want to show you guys.